So, good afternoon. Myself, Sreehari. I'm a third year MBBS student from AIIMS Nagpur. So, today's topic of discussion is thermodynamics. Actually, we are discussing this section in 8 different topics. That is, first is uh, what is heat and temperature, then thermal expansion, heat capacity, calorimetry, latent heat, change of state, and heat transfer and Newton's law of cooling. Okay. So first we should understand what is thermodynamics. Uh, First of all, thermodynamics is actually thermodynamics. Thermodynamics is a branch of physics. Okay. First, we should understand the basics very much clearly. Okay. Even though there is no definitions will ask in the question actually, but we should understand what is the definition and all, so that we can once the concept is very much clear, we can tackle the questions. Okay. So thermodynamics is the branch of physics. Okay. It is a branch of physics. First of all, deals mainly with temperature. It deals mainly with temperature, heat, and transfer of or interchange of heat, transfer or interconversion of heat. Okay, interconversion of heat. Okay, this is the just definition of thermodynamics. Okay, a little definition. Okay, now we can move to the important part. First of all, what is heat? First of all, there's a difference between heat and temperature. Heat and temperature are not same. First of all, we should understand what is heat actually. Heat is actually, it is a form of energy. It is a form of energy. Okay. Actually, it is a form of energy that we can transfer from one system to another system, or to the surrounding. This is the definition of heat. Heat is a form of energy that we can transfer from one system to another or to the surrounding. Next is temperature. Temperature is the measure of degree of hotness or coldness. Like here also we don't expect much questions actually, but we should understand what is the definition of temperature and heat, and we should understand both are not same. Okay, like I want to make you all understand that these are two different concepts and each have their own definitions. Okay, like once we are okay with the basics, like we can understand the complicated ones easily. Okay, fine. Now we are moving to the most important part of the session. Okay, that is the first law of thermodynamics. Okay, that is the first law of thermodynamics. See, what is actually first law of thermodynamics means? What is the first law of thermodynamics means? As per the first law of thermodynamics, like once we give heat to a system, like we all know what is a system and surrounding. System means the part of universe under observation. Okay, part of universe under observation. And the surroundings means it is the remaining part of the remaining of the universe. Okay, so once we give heat to the system, the system will use that heat to increase its internal energy, and remaining heat will used to do work. Okay, so we can write delta Q. Delta Q means heat given to the system will equal to internal energy of the system plus work done by the system. Okay, fine. Like next topic is heat capacity. like I will do the questions of both the first law of thermodynamics and heat capacity together. Okay, so you will understand, or you will have an idea of what is actually these two. Okay, so first of all, heat capacity. Heat capacity is actually, it is the amount of it is the amount of heat. It is the amount of heat required to raise the temperature. Raise the temperature of the system. By 1 degree Celsius. Okay, by 1 degree Celsius. So next is, what is specific heat capacity? Specific heat capacity. Specific heat capacity. Like, it is the difference between heat capacity and specific heat capacity is that heat capacity is the amount of heat required to raise the temperature of the system by 1 degree Celsius. In specific heat capacity, it is the amount of heat required to raise the temperature of unit mass system. Here it is unit mass system. Unit mass. For example, 1 gram, 1 kilogram, anything. Anyway, next is by 1 degree Celsius. Okay. Next is molar specific heat capacity. Molar specific heat capacity. In this case, instead of unit mass, it will be 1 mole substance. Okay, 1 mole substance. Like, we should understand the definitions very much clearly so that we can do the question. Now, section. So read the question. 100 gram of water is from, ignoring the slight, the given it is 4184 kilograms Kelvin. We know Q is actually M, mass of the system, into specific heat capacity into change in temperature. I think everyone should know the equation very much clearly. Okay, what is the mass given? Mass is given 100 into 10 raised to minus 3. Specific heat capacity for one change in temperature is 20. So we will get 8.4 into 10 raised to 3 joule. So it is 8.4 kilojoule. So we understand, we use here both the concept of first law of thermodynamics, that is heat given is used to do work actually. Okay, and plus heat capacity. Okay, so the answer is 8.4 kilojoule. I hope everyone understand what actually I mean heat capacity and first law of thermodynamics. Delta Q is equal to delta U plus W, and temperature, heat, everything. Okay, fine. So now we are moving to the next topic. Next question. Like, this is one more tricky question actually, but once the basic is clear, we can expect this type of like in physics we expect this type of definition. In an ice, the gas increases, the gas decreases, internal energy and average kinetic energy of the gas molecule decreases. So in isothermal expansion, means, I hope everyone know that isothermal means where delta T is equal to 0. Okay, we know internal energy, that is delta U energy is a function of temperature. So if delta T is equal to 0, delta U is equal to 0. So the answer remains so we covered actually we covered temperature, we covered thermal capacity, to lag clear about I hope everyone is clear. So before going to linear expansion, I want to know what is a temperature scale. Okay, like we don't want to know the details on, but I want to make you, I want all you understand a simple equation actually. That equation is actually, this is in a temperature scale, I'm writing here, in a temperature scale. Okay, that is thermometer. Okay, in every thermometer, scale, every thermometer, that is reading of the scale minus upper fixed, lower fixed point by upper fixed point minus lower fixed point is a constant. So we can write in Celsius scale, C minus 0 by 100 minus 0 is equal to F minus 32 by 212 minus 32 is equal to K minus 273.15 minus 373.15 minus 270.15. Okay, I hope everyone is clear about this equation. This equation is like we are not doing any questions from this, using this equation now, but we can expect this type of questions in the JEE mains exam. So once we know this equation, we can tackle every questions based on this from this question. Okay, like they can give a Celsius, like if 37 degrees Celsius is showing in 37 degrees Celsius is showing in Celsius scale, what can be the corresponding temperature in Fahrenheit or Kelvin? Like when we put the values in this equation, we will get answer for that type of questions. Okay. Now we are moving to what is linear expansion. Okay, what is linear expansion? Like this is a rod. Why? When we when we heat this rod, it will increase its length. Okay, that increase in length is called linear expansion. Okay, I hope everyone is clear about it. I don't want. Okay, linear expansion. So when a linear rod is heated, linear solid or whatever, material is heated, it will increase its length. That increases the length is called linear expansion. So we can find that change in length. I don't want, like here we just want to know that the equation is very much clearly. Okay, that change in length, that is delta L, is equal to L0. L0 is the initial length. Alpha is the coefficient of linear expansion into alpha delta T. Okay, so we can write alpha as delta L by L0 delta T, where alpha is the coefficient of linear expansion, coefficient of linear expansion. Now area expansion, same. Area expansion. Delta A, we can write A0 alpha, instead of alpha here, we have beta. Beta delta T. Okay. So we can write beta as delta A by A0 delta T. Same. We have volume expansion. We say like area expansion beta. Like in volume expansion, we have gamma. Gamma is the coefficient of volume expansion. Gamma is equal to delta V by V0 delta T. Like this much we know. And one more thing I want all to know to tackle the questions, that in case of solid, alpha is to beta is to gamma is equal to 1 is to 2 is to 3. Okay, This much things everyone should know. Okay, alpha, beta, gamma ratio is 1:3 in case of solid. Okay, like I'm using this much concept of linear area expansion, volume expansion to tackle the next question. I hope everyone is clear about this much topics. So we are using this knowledge to tackle the next question. Okay, let's see. Like I'll make you all clear by solving this question, so everyone will understand what is actually I mean. What actually I mean. Okay, so let's reiterate that volume of metal sphere increases by 0.24 percentage when its temperature is raised by 40 degrees Celsius. Okay, the coefficient of linear expansion of metal is dash degrees Celsius. Okay, fine. So what is actually given? Volume of metal sphere is increased by 0.24 percentage. 0.24 percentage. Okay, volume is sorry. So volume increased by 0.24 percentage. So volume, so it is actually given which one? Volume expansion. It is given volume expansion. Volume expansion is given. Volume expansion is 0.24 percentage. We can write 0.24 percentage as what? 0.24 by 100. Fine. I hope you already know. Okay. 0.24 by 100. Okay. So next is the coefficient of linear expansion. So they're asking coefficient of linear expansion instead of volume expansion. Okay, like we know gamma, that is coefficient of volume expansion is delta V by V into delta V by V into delta T. Okay, so the delta T is 40 degree. Delta V by V is 0.24 by 100. So we can write gamma is equal to 0.24 divided by delta V by delta V by V delta T is equal to 0.24 divided by 100 into 40. 100 into 40. That is 6 into 10 raised to minus 6 into 10 raised to minus 5. Minus 5. Okay, minus 5. Okay. 6 into 10 raised to minus 5. So we got what we got now? What we got now is volume expansion. That is coefficient of volume expansion. As I already mentioned above, that in case of solid, in the metal sphere is a solid, So in case of solid, alpha is to beta is to gamma is equal to 1 is to 2 is to 3. Okay. So if gamma is 6 into 10 raised to 5, what will be alpha? Alpha is gamma by 3. Gamma by 3. So 6 into 10 raised to 5 by 3 is 2 into 10 raised to minus 5. So we got the option 2 into 10 raised to minus 5. So I hope everybody is clear about this much topics. Okay. So now we are moving into the heat transfer, latent heat of fusion, latent heat of vaporization. Okay. So we covered heat and temperature, thermal expansion, heat capacity. Now we are moving to the calorimetry. Now calorimetry also we covered. Now we are moving to latent heat. Okay, latent heat. Now we have latent heat, change of state, and heat transfer. Okay, and Newton's law of cooling. So I hope everybody is clear about this much topics. So first of all, what is latent heat? Latent heat, it is the amount of heat required to change the state of the mass of a substance. Okay, it is the latent heat means it is the amount of heat required to change the state of a mass. State, it is the heat required to change the state. Okay, like from liquid to gas or gas to vapor, anyway. Okay, so when we see what is latent heat of fusion, this is important actually. What is latent heat of fusion? Latent heat of fusion means it is the amount of heat. It is the amount of heat required to change the state. In what state? From solid to liquid. Change the state from solid to liquid. Okay, at its melting point. Okay, at its melting point. So of how much substance? 1 kilogram of substance. This much terms should be in mind while solving the question. Change of state, which one? Solid to liquid. At what temperature? At its melting point. For water, it is 0 degrees Celsius. Okay. Or water or ice, it is 0 degrees Celsius. At its melting point, what is the mass of the substance? 1 kilogram mass. Okay. So I got an equation. Q is equal to L into M. Where L is the latent heat of fusion, and M is the mass of the substance, and Q is the heat given. So we can solve a question like, for a this much mass substance of latent heat of fusion of this much, how much heat is given? So we can find Q is equal to L into M. Q is equal to L into M. I hope everybody knows this equation very much clearly. Like we can't expect this much direct questions, but we need to understand the basics clearly. Once the basics is clear, we can solve the difficult question. Okay, fine. I hope everybody knows this much. Okay, like I'm just removing this. It's not needed anyway. We want an equation only that I will write. Q is equal to L into M, where L is the latent heat of fusion. Okay. And one more thing we want to know, what is the latent heat of fusion of water, or latent heat of fusion of ice? L ice. So I will write LF, so no confusion. Latent heat of fusion. L ice is 80 calorie per gram. Like in questions, they can give 80. The latent heat of ice is 80 calorie per gram. But it is good to know that the latent heat of fusion of ice is 80 calorie per gram. Like in some questions, sometimes they won't give. So it is good to know the latent heat of ice is 80 calorie per gram. Okay. Latent heat of vaporization. In here, the change of state is from liquid to vapor. At what temperature? At its boiling point. How much substance? 1 kilogram substance. So we can write same. Q is equal to LV into M. Where LV is the latent heat of vaporization. Okay. So LV water is equal to LV water or LV steam is equal to, I'll write LV steam. LV steam is equal to 540 calorie per gram. So always we should understand one thing. LV is greater than LF. LV means latent heat of fusion, vaporization is greater than latent heat of vaporization is greater than latent heat of fusion. Why? In case so while converting from liquid to gas or vapor, there is a huge change in the volume. There's a huge volume expansion. So that the reason that a huge volume expansion is there. For that volume expansion, we need more energy. So LV is greater than LF. Okay. One more point everyone should know. One more point everyone should know. That during phase change, during phase change, there won't be any increase in temperature. Why? That temperature is used for that to remove the inter-attractive force between the particles. So during phase change, delta T is equal to 0. This much basic points everyone should know. Now we are doing a question, so everyone should know. Okay. 80 gram of water, 30 degrees, 36 degrees Celsius, poured on a large block of ice, the mass of ice that melts. Simple. We know heat lost by a hot body is equal to heat gained by a cold body. Heat lost is equal to heat gain. Heat loss is equal to heat gain. Simple. What is the heat lost by the hot body? We know 80 into 30. What is the heat gain? We know it's a large mass of ice. So the mass that melts will get the heat. Okay. So we want to find that how much mass of ice is melt m into. We know I already told actually it is better to know the latent heat of fusion of ice. So LF of ice m into 80. So m is 30 gram. Simple. So I hope you understand this much clearly. Okay. Heat 80 into 30. Why heat loss is 80 into 30? What is 80 m? What is 30 T? We know Q is equal to m into L and m into delta T. Two equations I used here. This is the two equations I used. Delta T is 30, m is 80. Heat gain, m is the mass of the ice that melts, and LF 80. Okay. So this equation and Q is equal to m delta T. Two equations. Okay. I hope everyone is clear about this much topics. Fine. One more thing I want to mention actually, like it is anomalous expansion of water. Like it's a theory topic actually. I will just say actually, not writing much. Like generally when we heat, the volume will increase. Volume will increase while heating. But in case of water, at temperature from 0 to 4 degrees Celsius, when we heat, the volume will not increase. Instead, the volume will decrease. That means water contracts on heating and expands on cooling. From in this temperature range, water will contract on heating and expand on cooling. This is called anomalous behavior of water. This is the reason for the survival of aquatic life in cold winter time. Okay. Reason for the survival of aquatic life in winter. Like we can expect a theory type of questions here. So it's better to know this actually. Okay, fine. Okay. I'm removing this. Okay, I hope everyone understand the concept at least. Okay. Now we are moving to the another important topic of the today's section. Conduction in metallic rod. Conduction in metallic rod. Conduction. What is conduction? Conduction means here heat energy is transferred from transferred from one particle to another particle, without the movement of the particle, without the dislocation of the particle. Okay, here so the particle is not moving, heat is moving. Okay, like heat moves from here to here without the actual movement of actual movement of particle. So the particle here is not moving. Okay. So conduction, we can see conduction in solid, liquid, gas area, but solid shows only conduction. Solid show only conduction, but conduction can be seen in solid, liquid, and gas. Okay, fine. This much everyone should know. Okay. I want to know one more thing. Okay. I want you all to know one more thing concept. Okay. Now here we are not discussing about convection actually. We are discussing on conduction and a slight topic, that is Newton's law of cooling on radiation. Okay. So conduction, if it is a rod, see, it is a rod. It is a rod. Okay. Of area A, length L. Okay. So in conduction, we know heat, when we give a heat, it is moves from a temperature. We all know heat will move from higher temperature to lower temperature. T1 is higher temperature, T2 is lower temperature. So Q, I can write K into A into T1 minus T2, T1 minus T2 in a time of T by L. So Q is the heat given, K is the coefficient of thermal. Okay, K is the coefficient of thermal expansion. Coefficient of thermal expansion. Q is equal to K into A into T1 minus T2 into T by L. When I take Q by T means it is the heat current. Q by T is the heat current. I will write H is equal to Ka delta T by L, or I will write dq by dt is equal to minus Ka dt by dx, where dt by dx is the temperature gradient. Okay, one more thing you should know, that is thermal resistance. Thermal resistance. Okay, thermal resistance means R. I will write R. It is the thermal resistance means, we all know thermal resistance is H, heat current by sorry, one second. So okay, thermal resistance. Okay, next is thermal resistance. Like thermal resistance, I will write it is L by Ka. I will show you how it is, how I got that thing. L by Ka. It is L by Ka. Thermal resistance is actually H. Sorry. Okay. So thermal resistance is R is equal to L by K. So this is which we should know. Q is equal to Ka into T1 minus T by L. H is the heat current, that is Ka delta T by L. And once we write the heat current dq by dx, temperature gradient, and thermal resistance, that is R, is equal to L by Ka, where L is the length of the conducting body, A is the area of cross section, and K is the coefficient of thermal expansion. I hope everyone is clear about this much topic. Like we want to know this topics, this much things very much clearly. Okay. See, once doing a question, everyone will understand the thing. Okay. The ratio of thermal conductivity of two rods of different material is 5:4. The two rods of same area of cross section and same thermal resistance will have a length in the ratio. Okay. I wrote already R is equal to L by KA. I hope everyone know that actually L by K. No need to know how we got all. Okay. R is equal to L by K. And here they already mentioned that K1 by K2 is 5/4 and area is same and thermal resistance is same. So R1 equal to R2, K1 is equal to A2. So K1 by K2 is equal to L1 by L2. K1 by K2 is equal to 5/4. So L1 by L2 is equal to 5/4. So answer is 5:4. So option D. Okay, fine. Okay. So next question. Two identical square rods of metal are welded end to end as shown in the figure. 20 calorie heat flow in 4 minutes. 20 calorie heat flow in 4 minutes from this point to this point. Okay. And at a time period at a time of 4 minutes. So same amount of heat to 20 calorie here. The time is the question. T1, T2 already given. T1, T2 is given. T1, T2 is given. So as we all know the how to measure resistance in parallel and series connection. I know actually I hope everyone knows that. Okay. Sorry, I hope everyone knows that in series and parallel connection, how to measure the resistance. In series connection, R1. Okay. In parallel connection, 1 by R is equal to 1 by R1 plus 1 by R2 and R is L by K always. Okay. R is L by K. See, so what is the thing? Both the rods are identical. So R1 and R2 are equal. In series connection, R effective is, I am writing this is R, this is R, this is R, this is R. R effective in series, 2R. R effective in parallel. What is parallel connection? 1 by R is equal to 1 by R. 1 by R effective is equal to 1 by R plus 1 by R. So R effective is equal to 1 by 2R. Sorry, R by 2. Sorry. R by 2. Okay, R by 2. So we got R effective. Okay. Now they have told that time. So we all know that R is equal to, R is proportional to time. 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 So like when resistance increases, time is also increases. Okay. For 2R resistance, we need 4 minutes. So for R by 2 resistance, we need how much distance? We can write 2R divided by R by 2 is equal to 4 by X. That is 1 minute. Okay. So 1 minute. So we are moving the next part. Very much almost the time is going to over. So we are moving to the next part quickly. That is the Newton's law of cooling. So we should understand what Newton's law of cooling is saying. Newton's law of cooling is saying rate of cooling, that is dt by dt. This is temperature and this is time. Okay. Newton's law of cooling is actually saying rate of cooling. Rate of cooling. Rate of cooling is proportional. Rate of cooling is proportional to temperature difference of body's temperature and surrounding temperature. This is body temperature and this is surrounding temperature. Okay, but to solve the numerical problems related to Newton's law of cooling, we mostly depends on average, like average temperature form. Okay, average form. This one. T2 minus T1 by T is equal to C into T2 plus T1, C T1 by 2 minus Ts. This is the average, okay, temperature. Okay, like I will make you understand what actually this equation, how to solve a question with this equation. Okay, suppose a body of high temp, this T2 is the high temperature and T1 is the cold temperature. Okay, fine. So dt by dt is proportional to T body minus Ts. In average from T2 minus T1 by T is equal to a constant into T2 plus T1 by 2 minus Ts. Okay, fine. So I will make you understand how to solve a question based on Newton's law of cooling. Suppose a body of temperature, so we can say T2 is equal to 75 degrees Celsius. 75 degrees Celsius. It cooled. It cooled. Say T1. Okay. 65 degrees Celsius. At a time in a time period of 5 minutes. That is our T. Small letter T. Sorry. Small letter T. Okay. So with the surrounding temperature of 25 degrees Celsius, what will be the temperature of the body in next T in what will be the T in next 5 minutes or after 5 minutes? After 5 minutes. In after 5 minutes, what will be the temperature? Okay, so while we get a question like this, we should put everything in this equation. So what is our T2? 75. 75 plus 75 minus 65. 75 minus 65 by time is 4 minutes. So 5 minutes. Sorry. 5 is equal to T2 plus T1, that is 1, sorry, 75 plus 65 by 2 minus 25 into a constant. Okay. 2 is equal to C into 45. So C is equal to 2 by 45. So we will put these things in. So actually we want to find got the constant is 2 by, so we can find what will be the T after 5 minutes. Okay, again putting here T2 will be 65, that is a different, and T is the thing we want to find, and time is again 5 minutes is equal to 65 plus T by 5, sorry, 2 into a constant minus 25 minus 25, and we got the constant as, that is 2 by 45. So we will get T is equal to 57 degrees Celsius. Okay. This is how we solve Newton's law of cooling using average form. Okay. Average form. Okay. Average form. So temperature in this time, what will be the temperature of that body after after a particular time? Okay. So we will put an equation. With this, we can solve everything. Newton's law of cooling. It's a mostly asked question in JEE-Mains. Okay. So once more revise everything. So we started our topics of thermodynamics. Thermodynamics is conversion of heat into different forms, and we start the topic with heat and temperature by a form of energy. Heat is a form of energy which we can transfer from one system to another system or to the surrounding. And temperature is the measure of degree of hotness or coldness. And thermal Q is equal to delta U plus W, and heat is equal to heat given to system is used for changing its internal energy and used to work done. Capacity, we know that it's a temperature heat required to raise the temperature of the system by 1 degree Celsius, while in case of specific heat capacity it will be unit mass, and molar specific heat capacity will be 1 mole substance. So we know Q is equal to ms delta T, and we put that for using that formula we solve this question. Okay. In isothermal expansion, we know delta T is equal to 0. So the delta U is a function of temperature. So delta U is equal to 0. So in isothermal expansion, internal energy remains unchanged. And linear expansion, we have understand that delta L, alpha, beta, gamma, and alpha is to beta is to gamma. In case of solid, it is 1 is to 2 is to 3. And the latent heat of fusion and latent heat of vaporization. And we know Li is 80 calorie per gram, and V steam is 540 calorie per gram, and during phase change there will not be any temperature difference, that is delta T is equal to 0 during phase change, because that energy is used for removing the interattractive force between particle. And during conduction, heat will transfer from one part of the body to another part of the body without the movement of the particle. It will be seen in solid, liquid, and gas, but in solid it is the only way of heat transfer. We know thermal resistance is equal to R is equal to L by Ka, and heat current is equal to Ka delta T by L. And so using this formula we seen how to measure the thermal resistance of parallel and series connection, and also how to find the relations between L, Ka, and R using this formula of R is equal to L by Ka. And next is the most important topic, that is Newton's law of cooling. Newton's law of cooling is stating that heat lost by rate of cooling is proportional to temperature of the body and difference of temperature of body and surrounding. And using the average formula we solve this question, and this is one of the most expected question that we can expect from this part of rate of cooling, and we have solved it. Okay. If there's any query, you can put in chat box. Okay. So thank you.